Okay.
There's also an issue on the homework where it wasn't accepting fractions or decimals.
Either one?
Yeah.
I'd have to look at it. So how were you able to put your answer?
I didn't. I flagged the questions and I was
Okay.
going to go back to it.
Okay. I'll have to take a look at it. All right, I think this is the very last question. On the homework, if I remember right, or towards the end if it's not. And this is going to kind of lead into some of the things that we're going to do today. But basically what we have here is we have 3 right triangles, and we're going to redraw all 3 of those in kind of comparative, try to match up our sides, okay? And so I'm going to start with the small one up top. So we have sides of 2 and 1.5. This is what we call the hypotenuse, and this would be like the bottom side of the triangle. Okay, and then I'm going to do like a medium-sized one. And then I'm going to do a big one. Okay, the medium-sized one is this triangle right here, okay? I'm going to take out this 1.5 though. So it's this middle triangle here. This length here would be 7, and then the bottom side would be x. So it would look like that. Okay, and then the big triangle is the whole thing, so you would take out like these 2 parts on the inside. You add up this whole thing, so 2 plus 5 is 7, plus 3 would be 10. So my hypotenuse would be 10, and my bottom side would be y. Okay, so drawing out the 3 triangles, I think, is probably the best way to kind of visualize it and understand what's going on. And then I can use that to solve for x and y, okay? So for instance, if I wanted to find x, I'm not going to use this triangle at all. I'm going to use these 2 triangles right here. I'm going to say 2 is to 7 as 1.5 is to x. So we got to do x and y separately. So I would say 2 is to 7 as 1.5 is to x. And then you can cross multiply and solve. And we would do the same thing to find y, except I'm not going to use the middle triangle. I'm going to use this one and this one to find y. Okay. Hopefully that helps with that. Does that kind of make more sense on how to kind of work that one out, or at least redrawing it? Sometimes, and we're going to do the same thing today, redrawing these triangles, I think just separating them out is kind of a helpful way of kind of revisualizing the whole picture. Because the way it's drawn originally, what you can't do is you can't do like 2 is to 5 is 1.5 is to x. That's the most common mistake. I was even doing that at first, but we can't do that because we have to compare alike parts. We have to compare similar parts, which 2 and 5 are not necessarily similar, okay? Because we don't know if those sides are parallel. Okay. Questions about that? Hopefully that helps. If you still need some help, or if you have questions on yesterday's, there were some that were a little bit tricky yesterday. Let me know and I can help you out with that. All right, we are on 9.3 day 1. Like I told you yesterday, we're moving on to 9.3. So we're done with everything we're going to cover out of chapter 8, but we're adding this on to the end of chapter 8 because it kind of fits in with what we're doing with like similar triangles. I think it fits here better than it does with what we're going to cover and when we cover it in chapter 9, okay? These 2 problems are kind of helpful for what we're going to talk about the next couple of days because we're doing this in day 1 and day 2. We're going to set up a proportion here. And this is probably the most important thing is when you set up this proportion, you have some options, right? First of all, it already tells me the triangles are similar, so I'm not like trying to prove that they're similar or anything like that. We already know that they're similar, okay, which means they're in the same ratio to one another. So I have two options here when I set up my proportion. I can either go 7.5 to 1.5, but do we really want to use decimals? Probably not, right? We could. Probably would be better to use 15 to 3, right? If we had to choose between those two, it's all numbers, but probably whole numbers are better than decimals. So I would go 15 to 3. If you want to reduce that, you can. You don't necessarily have to, okay? So if you want to reduce it, you could reduce it to be 5/1. But you don't have to do that to do the proportion. What it does do is it gives me a little bit smaller numbers. So I'm going to use 5/1 instead of 15/3. But if you used 15/3, it would work out the same way. The thing we got to be really careful of here, as we've talked about, I got to go in the same order. So if I'm going 15 to 3, I'm going big to small, then I'm going to go big to small again. So then we would go x/2. And then we just cross multiply, and this works out pretty easy because then x = 10. You don't necessarily need to put 1x right here, because if I say 1x, that's really just x, right? And then dividing by 1 doesn't really change anything. So if you're cross multiplying with 1, you're not really needing to put the 1 there. Okay, this is the one that's really tricky, okay? This is a little bit trickier than the other. And what you have to pay attention to here is you have to pay attention to the markings. And kind of like what we talked about here just a second ago. One of the big things for today, I think it would be easier or better to redraw these two triangles. Because of the marking right here, this angle is congruent on both. And by redrawing this, this shows like the angle's in the same spot. The 90-degree angle is in the same spot. So here, this one is 9 is to x, and this one so that's what my picture would look like. Okay. Now here's what happens on this. This one's a little bit weird. 9 is to x as x is to 4. Okay, we're going left to right, left to right. You can go the other direction if you want to. But when I cross multiply here, watch what happens. X times x is x squared. 9 times 4 is 36. So we got to remember that when I take x times itself and we think, oh, we must have done something wrong because we're taking x times itself, it's going to happen like that sometimes, especially with the lesson that we do tomorrow. We're going to see some problems like that. So that's going to kind of lead into some things that we're going to see. How do I solve x squared equals 36? Got to square root it, okay? And typically, if we were going to square root this, I would say that my answer is really plus or minus 6. But because we're talking about the length of a side, would it make sense for me to say that this side length is negative 6? No, because we're actually talking about a triangle. X is the side of that triangle. Okay, so negative 6 does not work. So my answer would simply just be x = 6. But there are going to be times where when I solve using a square root, that both positive or negative answer might be a possibility. Okay, and that kind of goes a little bit back to Algebra 1 again, where we kind of remember those square root rules and things like that. It's been a while since we've seen some of them, though. Okay. And these problems here, okay? When we look at this picture, and this kind of goes back to the one I did just a few minutes ago from yesterday's. It's not the exact same thing. But what we have here is we have 3 triangles in this picture. We have the big one. And then we have the one on the left right here. And then we got this smaller one right here. Okay? The goal today is going to be to redraw these triangles and try to draw them in a fashion where they all match up with one another, okay? And I'm going to show you on this example down here what that would look like. But if I were to redraw these three triangles, for me, what I think is probably the most helpful, you're going to have a small one, a medium-sized one, and you're going to have a large one. So I'm going to keep going to small, medium, and large, okay? And I want to draw all three of them the same way. Thank you. The one that we have to begin with that looks just like these three is this one that's in the middle right here, this one on the left-hand side, okay? So I'm going to label this one ABC. You can draw these any way you want to, but I want you to try to draw them all three the same way. And I always like putting my 90-degree angle on the bottom rather than putting it up here. So that's why I'm not using the big one to start with. If you wanted to, you could. Now, as we look at these three sides here, and this is going to be the part that's a little bit tricky, okay? DC here, and I didn't draw my triangles great here, DC is a little bit shorter than AB. So what we're going to have here is we're going to have a hypotenuse. The hypotenuse is going to be opposite the 90, okay? That's the easy one to determine. And then we're going to have a short leg and we're going to have a longer leg, okay, on all of these triangles. So on this big one right here, C is the 90-degree angle. That's the easy part. C is my 90-degree angle on the big triangle, okay? CB is going to be the short leg. And then CA is going to be the longer leg, which is right here, okay? That's on the big one. Okay, for this little one right here, D is going to be my 90. The short leg is going to be DB. And the longer leg is going to be this right here, which is DC. Those are my three triangles, okay? We'll try to give you triangles that are easy to determine short leg versus long leg, because sometimes it could be a situation where it's really kind of hard to determine the difference between the two, okay? And as we look at what it's telling me to do here, is it's trying to tell me the similarity here, okay? So for instance, when it says ABC, ABC is similar to ACD. CBD is similar to ACD. All three of these triangles are all in the same order with one another, as we've been talking about now for the last week or so, okay? As we look at these, then following the path, the parts that match up, is really the big deal, okay? And so that's the thing that we're going to have to really pay attention to here. This really isn't anything. This is just showing you that they took the two triangles and separated them. I would rather redraw them all the same way. I think visually that's the way to go. Because trying to decide what matches up when they're all sitting differently, I think is kind of hard. If you draw all three triangles, and probably I should have done a better job this first time around, especially this being the short leg, this being the long leg, and probably drawing them a little bit better. And I didn't do a great job drawing them the first time around here. I'll try to do a better job when we redraw them, so it's easier to kind of see. Here's the short leg, here's the long leg, here's the hypotenuse. Hypotenuse is always opposite the 90, okay? So that's essentially what we're going to be doing on these problems today. Okay, so here's the first thing that I would do on this problem. It says to identify the similar triangles. Now, can you do this without drawing the picture? Yeah, but I would say you're going to have a whole lot more success if you do it by redrawing it, okay? And I know it takes a little bit of time to redraw these, okay? But I think it's well worth it. So I'm going to draw a big one.
I'm going to draw a medium-sized one. And then I'm going to draw a little one. Okay, in all three of these, we got a 90-degree angle. Okay, so we're going to take that 90-degree angle, okay, and we're going to label the parts, okay? The first one here should be kind of easy, right? Because the big one is the one that we have sitting just like it is. So we've got R, T, S, T is my 90, right? So we're going to label this one R, T, S. That's my large triangle. Okay, the medium-sized one, I'm going to cover this guy up right here. Okay, it's going to be this one sitting here on the left. My 90-degree angle is U right there. That would be usually where I start. Label the 90, U. Hey, on this triangle here, the shorter leg is UT. The longer leg is UR. And then we do the little one. We do this one right here. Okay, I know there's no 90 in here, but we know U is still the 90, because if this is 90, the one right next to it's got to be 90, right? So this is still angle U. It's just U on the other triangle. The short piece is US. The longer piece is UT. Those are my three triangles. Okay. Now we have three triangles that all look the same. And now writing my similarity statement should be a lot easier. Okay. And here's what you can do. We're going to start with the one on the left. And you can start with the one on the right if you want to, but I'm going to start on the left. The first triangle, you can name it any way you want to. I'm just going to go alphabetically. RST. I'm going to work my way around it. Okay. Clockwise. RST. And then I'm going to move over here to the second one. I'm going to go in the same order. We're saying these are all matching up, right? So we're going around. We're going to start down here again, okay? And we're going to go around RTU. And then the third triangle, starting in the same location, we're going to go clockwise around the triangle. We're going to go TSU. Once we have the pictures drawn, identifying the similar triangles should be a little bit easier. Trying to do that without looking at the pictures and having them redrawn, a little bit more difficult to do. It's not impossible, okay? And if you're one that can kind of visualize what it would look like without redrawing it, more power to you. I think that's sometimes a little bit harder to do. Okay. Try this one. See if you can redraw these three triangles and see if you can label them. Okay. I'm going to kind of do it as you guys do it, and we'll see what we can do here. Three right triangles. way that I kind of start is I always kind of like to start with the big one if I can, or the one that's sitting with the 90-degree on bottom. Okay, so I started with the big one over to the left. If you want to start with the small one, you can start with the small one. Big one's on the far left. That's the one that we began with, right? QSR. I labeled them all. We don't put this line in the middle of it. We just draw it as its own triangle. Okay, and this one I would say we're kind of getting to the point where sometimes it's kind of hard to determine what's going on here. So QT is a little bit shorter than ST. So QT is going to be this one here, okay? ST is going to be this one. That's the small triangle. The medium-sized triangle, TS is going to be this side, and then TR is going to be the bottom side, and then SR is my hypotenuse. Okay, those are my three triangles. They don't necessarily have to be drawn just that way. They could be drawn a different way, but the biggest thing is they should all look the same, okay, to make things a little bit easier. Okay, and then you can name it however you want. The first one, I could say QRS, QSR, RSQ, any order you want to put them in. Typically, I might pick alphabetically, QRS. It doesn't have to be that way, but what it does have to be is that the other two have to match up with that one the same way. So I start with QRS. I start with this top point, and I just go around clockwise, around the triangle, right? QRS. So here I'm going to start with S, right? And I'm going to go SRT. And then QST. All starting in the same spot, all going in the same order around the triangle. If you had started with a different letter, like let's say I started with S or started with R, then these are going to be in a little bit different order, right? Because they're going to match up. Similarity. Okay, how do we feel about that? How do you guys feel about drawing these out? Hard, or does it make sense, like kind of how to match up the things? Okay, it is a little tricky, okay? But once you get the hang of it, I don't think it's too bad. I'm not going to make you do one like this. We're going to skip this one because I think it's really hard to determine which one's the long leg and the short leg. They look pretty close together. So if I'm going to give you a problem like this, I'm typically going to give you one that's pretty easy to determine what goes where, okay? So I'm going to skip this guy right here. Okay, on this one up here, we are trying to find the height of the roof. Okay, a couple of different ways that we could do that. First of all, if you wanted to redraw it the way that that one's drawn, you can. Once again, I kind of like drawing. Here's my big one. Here's my medium one. Here's my small one. Okay, the big one is the big thing right here, right? It's all of the outside pieces. So the hypotenuse, here's my 90. So angle Y is 90 degrees. The hypotenuse is across from angle Y. So the hypotenuse is 6.3. The short leg is 3.1, which means the bottom side is 5.5. Okay? That's my big triangle. The whole thing. All three sides are labeled. Okay, let's look at the medium-sized one. We don't know the bottom side, right? We don't know what the length of the bottom side is. All that we know is the height is h, the hypotenuse is 5.5. We don't know all three sides. So I'm not going to label the bottom side because we don't know for the little triangle right here, my 90-degree angle is still W. On this one, we don't know WX, but we do know the longer leg, which is H. And we know the hypotenuse is 3.1. Okay, the goal here is to solve for H, right? H is what we're looking for. And do you need all three triangles? Probably not, okay? I can either, so the reason I tell you that is because maybe I don't draw this triangle out. I can simply use these two triangles to solve for H, right? Or maybe I don't need the medium-sized triangle. Maybe I do the small one and the big one. I definitely need the big one because the big one has all three sides, right? The big one is the one we definitely need because when I match up pieces, then that'll make things easier. Okay, if I use the medium one with the big one, what two sides do I know both lengths to? These right here. Okay, these are the ones I have to start with because that's the one I know both lengths to, 5.5 and 6.3, right? So we're going to go 5.5 over 6.3. And then we're trying to find H. So we're going to go H matches with 3.1. I never even used the 5.5 on the big triangle, right? So now what we're going to do is we've got a proportion, we're going to cross multiply, and we're going to solve. Okay, the easiest way to solve this one is to take 3.1 times 5.5 and then divide it by 6.3. Okay, we're going to get an approximate answer. So let's put that into your calculators. 5.5 times 3.1 divided by 6.3. What do we get? Let's round to the nearest tenth. Okay, 2.7. And that would be my answer. Okay, because it's a story problem, because we're doing actual length or the height of this roof, then we may not come up to be an exact answer. Okay, we're just going to kind of round it, come up as close as we possibly can. On your homework today, there are going to be times where it says find an exact value. If it ever says find an exact value, then we'll probably leave our answer as a fraction instead of a decimal. Okay, but if we're doing a story problem, the fraction really doesn't make sense. I don't go into Lowe's and say, hey, I need this board. Can you make it 40 feet long? Right? That'd be kind of silly, right? They're going to look at me a little bit different. I'm going to need a board that's about 13.5 feet long. It's probably going to make a little bit more sense to the guy that's going to cut it for me, right? So we don't typically, when we're talking about actual length, we don't talk in fractions or radicals or anything like that. We talk in actual feet or inches or whatever we need.
Will they stop you though?
Will they stop me? I don't know. That's a good question. Depends on who you get. I always kind of like to mess with like former students when I go in and do
Likeness
that.
can be tested.
Yeah. So if it was a former student that was can you make me a piece that's 40 feet long? Or if I go through Dillon's and somebody's like checking me out, that's a former student, can you count that change back to me, please? I'm kind of dirty like that sometimes. Make them nervous. All right. So we probably won't do both of these. Let's do the one on the bottom, okay? Once again, we got a small one. We got a medium-sized one. And then we got a big one. You may not need all three, okay? Maybe you just label two of them. And you kind of decide, okay? The one that I know all three lengths to is the big one. It may not always be the big one, okay? But that's what we have on the last one we did and on this one. 5, 12, and 13. That's the one that we definitely have to have because we already know all three lengths to it, right? Our goal is to find x. That x is going to be in different places on these two triangles, but it's still the same x, right? The x here is the same no matter what side it's on over here, because it's the same side. On the small triangle, it's the long leg. On the medium-sized triangle, it's the short leg. But it's the same side, right? It's still x. So do we want to do the medium one or do the big one? Or the medium? Or the medium or small? Which one do we want to do? What do you guys think? To me, I think maybe the small one would be a little bit easier here, because this is the longer leg, right? So that's going to be x, and then this would be 5. We don't know the short leg. It's not labeled. And we don't have any way of finding that. Okay, if you wanted to do the medium one, just so you can see it here, the short leg would be x, the hypotenuse would be 12. Okay, so you got to have one or the other. If you want to do both and check it and make sure they're both the same answer, that's fine. But you don't need to do it twice. Okay. So let's go small and big. Okay. So what two sides on the small one and the big one do we know both lengths to? 5 and 13, right? It's the hypotenuse. It's 2, 13. So really, I'm just covering this one up. I'm not even paying attention to this medium triangle right now. Okay? So maybe don't even draw it if you're not going to use it. That way it doesn't confuse you. And then if I'm going to find x, what side does x match up with? 12, right? That's the purpose of redrawing these. Once it's redrawn, if I redraw it correctly, it's really easy to see what goes with what, right? Otherwise, if I try to look at that original picture, it might be kind of harder to determine. But now 5 goes to 13 as x goes to 12. The hard part today is setting up the proportion and drawing the pictures. Okay, that's why I've spent so much time on it. Once I got the proportion set up, this is not the hard part of the problem, hopefully, because we've done this for the last week or so, right? That's skills that we've already been doing. Now all I got to do is cross multiply and divide. When it says to leave your answer as an exact value, this is what we kind of talked about yesterday. 5 times 12 is 60. So it would kind of look like this. And then I divide by 13. And so my exact value here would just be 60 over 13. And that's how I would leave my answer. So on Big Ideas today, if it's asking you for an exact value, don't go to a decimal there, okay? That's not going to be a nice whole number there. 60 doesn't divide by 13 evenly. If it divides evenly, then I can divide it, and that's my answer, okay? If it's 60 divided by 12, I would get 5. 5 is my answer. But if it doesn't divide evenly, try it first. See if it divides evenly. If not, we leave it as a fraction, okay?